So far we have seen the various techniques for finding the peak element in a sorted array, right? Now let's quickly write the JavaScript solution for the same problem. So since it is our first searching specific practice problem that we are trying to implement, what I want to do is inside the searching folder, whatever we have created for organizing all the searching specific implementations, there let me just create one folder called practice. Inside this practice folder, let me just create one file called findPeakElement.js. Okay, inside this file, let's just write the solution for the same thing. So here let me just define one class called findPeakElement. Okay, and inside here let me just define one function called findPeakElement using binary search. Okay, so whatever the other techniques that I have explained are not the effective way to find the peak element, so I'm not going to write the solution for the same thing. Anyway, we have discussed all the approaches thoroughly one by one, right? If at all if you want the programming specific implementations, you can go to codingpal.org and find out the solutions there as well. I'll put the relevant link to this problem in the description box below so that you can go ahead and check it out. Okay, so here let me just pass the array as an argument. Now, so the first case that we need to handle here is whatever the array that we are passing, right? It could be an empty array. Obviously in the empty array there is no peak element, so we need to return the index -1. So here for that, first let me just create a variable called length and let me just read the length of the array. Once I read the length of the array, if at all the length is equal to 0, that means that array that I have got is empty. In that case, I will simply return -1. Okay, if this is not the case, that means that the array is not empty. In that case, what we will do, we will apply the binary searching, right? So according to the algorithm that we have discussed, we will define couple of variables, start and end. This end will basically hold the last index inside the array, which is nothing but length -1. Along with that, I will also define one variable called middle, and I'm going to initialize it with -1 as well. Now what we will do is we will run a loop as long as start is less than end. Here what we will do, we will calculate the middle. Middle basically is nothing but start plus end divided by 2, right? It will basically give us a floating point result. So to convert it into a whole number, I will simply do math.floor. So here start plus end divided by 2. Okay, now I have the middle. Now all I do is I will compare this middle value with middle plus 1 index's value. So here, if at all the value I have at this middle index is less than the value I have at middle plus 1 index. Sorry, I forgot to define the types here. I need to define let, right? So that is what here we need to do. Okay, so if at all the value at the middle index is less than the middle plus 1th index, that means the larger value is there on the right side. For that, what I will do is I'll simply update start to middle plus 1. If this is not the case, that means the value we have on the middle is greater than or equal to the value we have at the middle plus 1th index. That means the peak element will be there on the left part of the array only. So for that, what I will do is end is equal to, I'm going to update it with middle only. One thing that you need to notice here is I'm not updating the end with middle -1. I'm just updating the end with middle itself, because whatever the middle that we have right now is holding the greater value, right? That means it itself could be the peak element. So the search span should limit to start index till the middle index whatever we have. That's the reason why I'm updating this end with middle itself. Okay, once we are done executing this while loop, whatever the start index we have, that means whatever the value we have inside this start will be holding the index for the peak element. So we will simply need to return start itself. Okay, so that is the way of finding the peak element inside a sorted array using the binary search algorithm. Okay, now let's just try to call this function and validate the couple of scenarios. So first let me just define an array. Let array is equal to 1 2 3 4 5 0 1 2 3. Okay, so here the input is according to the pattern that we have got inside the problem statement. Along with that, let me just define the object of find peak element class, and along with that let me just create one variable index, and using the reference of fp, let's just call the peak element find peak element using binary search, and let's just pass the array to that. After that, let's just try to log index. Okay, now if you look at the array of values that we have got here, there are two peak elements. One is 5 and the other is 3. You can return the index of either 5 or 3, that is completely up to you. Let's run and see which one we will get. So if you look at here, the output that we have got is 4. If you look at here, index 4 has the value 5. So 5 is a peak value in the array as well. Okay, so it is successfully evaluated. Now let me just remove some part of the sorted array, and right now we have only 1 2 3 4 in it. So if I run this code now, 4 is the peak value, right? So we've got index 3. Index 3 is nothing but the position for the value 4 inside the array. Now similarly, let me just run it on an array which has only one value. So if it has only one value, it itself is the peak element, right? So index 0 is what we have got. Likewise, if I pass an empty array, it should return -1 because there are no values inside the array. Okay, we have got -1 as well. Okay, so that is how we implement, finding the peak element inside a sorted array solution using binary searching, covering all the scenarios. Okay, so that's it for finding the peak element inside an array. I'll see you in the next problem.